Hey everyone, and welcome. Today, we are going to crack the code on your MYP science assessments. Seriously, we're going to pull apart the official rubrics, look at some real student work, and figure out exactly what you need to do to turn a pretty good grade into a fantastic one. All right, let's dive in.
So what is the big secret to getting that top score? Is it just about cramming more facts into your brain? Well, not exactly. The secret isn't buried in your textbook. It's actually hiding in plain sight, right there, in the assessment criteria your teacher uses. You just have to think of it less like a set of boring rules and more like a secret map to success. And the key to unlocking that map? It's all about understanding the command terms. You know, those specific action words like outline, describe, explain, or evaluate. These words are literally telling you exactly what your teacher is looking for. Knowing the difference between them, well, that's what separates a good score from a truly great one.
So here's our quest map for today. First, we'll crack the MYP science code itself. Then we'll journey through each criterion. We've got A, knowing your stuff, B, designing your quest, C, making sense of data, and finally D, the bigger picture. And don't worry, we'll wrap it all up with the ultimate cheat sheet.
You see, every science assessment you do in the MYP is basically a quest with 4 trials. These are the 4 criteria you're graded on, and they cover the entire scientific process, from what you know at the start to your final thoughts at the end.
So here they are, the big 4. Criterion A is all about what you know. B is how you plan an investigation. C is what you do with the data you collect. And D is about connecting all of your work to the real world. If you can master all 4, you're on the path to the top.
Okay, let's kick things off with criterion A, knowing and understanding. Now this is about way more than just memorizing facts for a test. It's really about how you use that scientific knowledge to solve problems and make smart judgments.
And just look at the wording here for the highest level. It's not just explain or apply. It's analyze and evaluate. What that really means is you need to start thinking like a real scientist, questioning claims, looking at how other people did their experiments, and forming your own conclusions that are backed up by solid evidence.
Next up, criterion B, inquiring and designing. Think of this as your blueprint for discovery. It's where you design a whole scientific investigation. And let me tell you, the difference between a good plan and a great one is all in the details.
Look at how these command terms build on each other. At the lower levels, you just state or outline your plan. But to get into that top 7-8 band, you have to explain it. And that means giving a super detailed account with reasons for your choices. Why did you pick that variable? Why are you following that procedure? You gotta have the answers.
This little comparison says it all. To outline your controlled variables, you can just list them. Easy enough. But to explain them, you need to justify why they have to be controlled and then detail the exact steps you're going to take to keep them the same. Let's look at a real example.
All right, here's a snippet from a student's lab report. They've correctly identified the controlled variables, which is a great start. This is a solid outline. But is it an explanation?
And there it is. The teacher's feedback cuts right to the chase. The teacher is asking for the how. What will you do? That simple question is the key. The student needed to add the specific actions, like, I will use a thermometer, and I will only keep the power on for 10 seconds at a time to prevent heating. See? That detail is what turns an outline into a top-level explanation.
Now for criterion C, processing and evaluating. So your experiment's done, you've got a table full of numbers, now what? Well, now it's time to find the story that your data is trying to tell you.
So a key term you'll see for the highest levels of criterion C is transforming data. This isn't just about plotting your raw numbers on a graph. Nope. It's about playing with them, manipulating them to maybe find deeper patterns. Things like calculating averages, finding the rate of change, or even creating brand new values to graph that might give you a nice straight line.
So here's that same student's conclusion. It correctly states the relationship they found, and it confirms their hypothesis. This is a good interpretation of the data, and it totally hits the requirements for the lower levels. But something's missing, right?
And once again, the teacher's feedback shows us the way up. Could you have explained the results? A top-level conclusion doesn't just say what happened. It uses actual scientific reasoning to explain why it happened. Why does a thicker wire have less resistance? It's all about connecting your data back to the science. All right, on to our final trial, criterion D, reflecting on the impacts of science. This is where you connect your findings to the bigger picture, to society, ethics, the environment. A really important part of this is just communicating like a scientist, and that all starts with properly crediting the work of others.
Okay, and this is a big one. A massive part of being a good scientist is giving credit where credit is due. And in the MYP, this isn't just, good manners, it's a skill you are explicitly graded on. Not documenting your sources correctly is a pretty serious academic issue, and it can really drag down your grade in Criterion D.
You can see the path to a top score so clearly here. You move from just a messy list of links to a perfectly formatted bibliography with consistent in-text citations. Using a recognized style like MLA or APA and getting all those little details right, authors, dates, all that stuff is absolutely non-negotiable if you're shooting for a level 7 or 8.
Phew, we've been through a lot of detail, so let's pull it all together into one powerful summary. Here it is, your ultimate cheat sheet for leveling up your MYP science grade.
Honestly, this table is everything. Just look at the verbs. A good answer outlines, interprets, and describes. But a great answer analyzes, explains, and evaluates. It moves from just stating facts to providing reasons. It moves from just accepting a method to actually questioning if it was any good. This is the leap you need to make. So look, if you take only one thing away today, please let it be this. The real secret to acing your MYP science assessment is to consistently move beyond describing what you did or what you found and start explaining why. Why that hypothesis, why that method, why those results. The why is where all the top marks are hiding. So now you have the map. You understand the command terms. The only question left is, on your next lab report or research project, which part of your quest are you going to focus on leveling up first? Are you going to add more justification to your method in Criterion B? Or maybe try to evaluate your data in Criterion C? The quest is yours. Go for it.